Okay, so hello everybody. I'm Aldo Lipani. I'm assistant professor at University College London. So thank you everyone for taking part in this question answering session of SCAI'22. So for those of you who have not attended the previous ones, these sessions are basically divided in two parts. So there will be like talks at the beginning, and then we will have a panel discussion with the presenters of the talks. So we have selected four works. So we will have four talks, which will revolve around the topics of answering conversational questions, entity linking, and question generation. So the first one will be Gonçalo Raposo from the University of Lisbon, which will kick off the session by introducing the task of conversational question answering from passage collection and briefly describing the state-of-the-art approach for this task, as well as the major challenges it faces. After that, we will have Philipp Christmann from the Max Planck Institute for Informatics, who will introduce their new dataset for conversational question answering over tables, knowledge graphs, and text, and how such an approach may help to complement or support answers available from a single source only. Then we have Hideaki Joko from Radboud University. He will talk about entity linking for conversations that allows to ground conversations to knowledge graph, and he will show that off-the-shelf tools do not really work with conversations. After that, we will have Carlos Gemmell from the University of Glasgow, who will describe the architecture of the GRILLBot, so the winner of the first year Alexa Prize TaskBot challenge. And in particular, he will focus on the zero-shot question answering and question generation approach. So we hope that with these talks, we will give you a good representation of the problems existing in conversational question answering, and thanks also to the last talk that we will go from the conceptualization of the problems to their implementation. So after each talk, we will have time for some questions. By the way, all the presenters are online, so are here in person, but with the exception of the first one, but they will be all able to answer questions after each talk. So I think we can get started. The first one is Gonçalo Raposo, and this talk that he will be presenting stems from his work done in this year and published in this year ECIR titled Question Rewriting, Assessing its Importance for Conversational Question Answering. So, Gonçalo, you can start.
Okay. Can you hear me?
Yes.
I guess. Okay. Thank you for an introduction. I'd also like to greet everyone there in the conference and the other speakers. So my work, as it was just announced, is question rewriting, assessing its importance for conversational question answering, which resulted from our work in last year's edition, but I'll get into more details later. I'm a second-year PhD student. I'm supervised by Luisa Coelho and Bruno Martins, and I'm from Portugal, although I'm not in Portugal right now. That's why I wasn't able to go to Spain, which is just besides Portugal. So, as an overview, this paper was resulted in a short publication, and the system that I'm going to present achieved first place in the last year editions of this shared task workshop, of SCAI workshop. We completed as Team Rachel, and all the codes we implemented is available, so feel free to experiment with it. In the problem of conversational question answering, the main difficulty are the conversations, which are highly context dependent, and thus we'll have to implement some techniques to deal with that. More than that, in the open domain scenario, many questions usually require some particular knowledge facts, and we'll have to have a way to fetch those. And at last, having those knowledge facts, we'll have to have a way to summarize everything into a single answer that fits the dialogue properly. Thus, our approach divides it in 3 different steps or 3 different modules. And starting from the left in the figure, we get a conversation, and it passes through a question rewriting module. That what it does is to reformulate the last question and make it independent of the previous ones. That is, it replaces pronouns, acronyms, in order to get one single question. Then, having that question, we use it to query a database of text passages and retrieve those with information that will be relevant. And then at last, we have a last module that receives the passages, the written question, and just generates an answer that in principle should fit the dialogue. In terms of our implementation, for the question rewriting, we used a T5 transformer model, which was fine-tuned for this task, but we got it from Hugging Face. Then for the passage retrieval, we simply performed sparse passage retrieval with the BM25 blocking function, which we implemented using Pyzarini, the Python toolkit. And at last, we used another transformer model, this one called Pegasus, which was pre-trained in a task similar to summarization, and then we fine-tuned it with the QRECC dataset. And speaking about the datasets and the shared task, the goal was thus to answer a question given a conversation history, and it was able to retrieve a passage from Common Crawl and Wayback Machine, which total on about almost 10 million passages to retrieve from. So here is an example of a sample and our system response. So it gets a context and it consists of questions and answers. Then the system will rewrite the last question. So the original question was, what was the result? And if the system only got this, it wouldn't know what it was referring to. But the question rewrite receives the entire context and rewrites the question into what was the result of the chart of the light brigade. Then the passage retrieval, it retrieves many passages, but this one was the one with this was the URL of the one with the highest score. And then using the most relevant passages and the question, it generates an answer. And here it is. It is well written, and not only the piece of information that answered the question. Now this table might seem a bit too large, but it covers all the main results of our work. The first 3 lines are baselines provided by the workshop organizers. And then we studied many ways of performing the question rewriting. And we saw that with question rewriting, we were able to improve the score over the baselines, even the GPT-3 one. When we even tried with the ground truth rewritten questions, and the score were even higher, almost double. So there is still work to do in the question rewriting. Then I have 2 plots. This might seem a bit difficult to understand at a glance, but what it says is the impact of the question rewriting for each module. So for the passage retrieval, the plot on the left, we observed that when the question rewriting was successful, the scores of the passage retrieval were also better, as we would expect, and the same can be said for answer generation. When the rewriting was successful, the answer generation also obtained higher scores. And that's it. It's a small presentation. So our system consisted of 3 modules: the question rewriting, passage retrieval, and answer generation. All our experiments with question rewriting exhibited higher scores than without. So question rewriting seems to help in this problem. And more particularly, when we introduced question rewriting, both the retrieval and answer generation improved about by a factor of about 2. As for future work, we would like to study how to improve the question writing module, for example, doing some self-critical sequence training, validates the importance of question rewriting with other data sets and models. We only tried in the shared task data set. And then as a more high level, explore how to control question rewriting and how to better connect it, or how it affects passage retrieval. And that's all. Thank you very much. If you have questions, I don't know if you're going to ask now or in the end, but feel free. And I also prepared this demo that you can try. It is the system that we implemented for the shared task, but as a disclaimer, it doesn't work very well with concurrent requests. So yeah, have that in mind. Thank you very much.
Right, thank you, Gonçalo, for the presentation. Do you have any questions in the audience? Yeah, please.
So one of the questions I have with the query rewriters that we've seen in CAST, for instance, is they fail in a lot of scenarios that where the context is either ambiguous or there are many, many entities in the context of the answer or in the previous context of the utterances. Can you describe a little bit what kind of behavior you've seen where these systems fail, and what is the path forward that you see that's actually viable given the sizes of the data sets that we have?
Of course. So that is true. We analyzed some results and we saw that in many fail cases, the problem was in the first step, the question rewriting. For cases where an entity can have more than one meaning, I remember one example where it referred to the color pink, but the question rewriting module thought it was referring to the artist Pink, and so then it just diverged, and we didn't have any mechanism to take it to the in the correct path. But in order to maybe improve the question rewriting, as we implemented it, the question rewriting is simply a transformer, and so it behaves like a black box. We didn't implement any way to control it. Maybe we could try generating multiple question rewriting outputs. Since it is a generative model, we could try to generate many possibilities and then use some other model to rank them. But it would be hard because I think it really depends. There are some cases that might be obvious, even for us humans to distinguish, and that might be easy to implement. But there are some cases that without the right context, it would be hard, even for us humans. Maybe a more complex way would be to introduce some retrieval for the question rewriting. It might be a bit overkill, but introducing some external knowledge in the question rewriting might be helpful. But then we would have to see if it was necessary to do the question rewriting at all, or if the introduction of new knowledge could be performed only by, for example, our second model, the retriever.
So basically, what you're saying is that the question rewriter is based only on the linguistic patterns, or it's also based on what the search engine has retrieved?
No, the question rewriting is performed using a transformer model. So all the knowledge that is introduced comes from the pre-trained weights of the transformer model. I don't know if it answered the question or not, but the transformer model was trained in a data set of original questions and rewritten questions that was obtained through human annotators.
So then the question rewriter may just come up with a new concept that doesn't exist in the
Yeah, exactly. Yeah,
okay.
That's the problem with transformers. I mean, vanilla transformers.
Do you have already an idea how to improve this? I mean, correct this problem?
It's a bit hard to say right now. Maybe with some kind of maybe another transformer like a cross encoder trained in natural language inference to check if it makes sense with the context. But I don't have a straightforward answer to that.
All right, so we have a question from an anonymous. So how
Yeah.
did the maximum sequence length of the model affect using the dialogue history?
Okay. Actually, not at all. So for the question rewriting module, the T5 model, the input size was 512 tokens, and which was able to cover practically the entire context. And maybe more critical would be the answer generation, which would take all the retrieved passages, and those could grow very large. We used Pegasus for that, and it was able to take 1,024 tokens. And surprisingly, it covered, it was able to take about 3 to 4 entire passages along with the written question. So it didn't have many problems in that scenario, but other ways of augmenting retrieval augmented generation could be more efficient memory-wise, but we didn't study those. But okay, we were able to answering the question. We didn't have many problems with that, and it will depend on the tokenizer, the way it splits the text into tokens, but we didn't have many problems with that.
Okay, do we have any other question from the audience? Yeah.
Hi, thank you for your talk. It was just because I'm not familiar with the dataset, and
Yeah.
I noticed that the exact match is very low, and also that the model gives, like instead of giving a concise answer, it gives a whole sentence.
Yeah.
So,
Yeah, I can give some new details about that. So the task is conversational question answering. So the idea is indeed to return an answer that is a complete sentence and not only the piece of knowledge that answers the fact. So this would be used for a conversational system to which we would be able to ask any questions, and the system would answer it naturally. In terms of the exact match being so low, it comes from the fact that it is being used to evaluate dialogue. And the exact match will just check if the sentence that we generated is exactly equal to the ground truth answer. And since we are generating dialogue, if we change only one word, it is different from the original one, so it would be a miss in the exact match score. So that's why it is so low, because it is being used to evaluate dialogues, and there are many ways to say the same thing.
Okay, thanks.
okay, thank you.
Thank you.
Actually, I was wondering, does your model already work when the user changes topic, for example, or it gets stuck to the original topic?
It does. It depends on the question rewriting, but the data set that was used for the question rewriting, CANAV, if I remember correctly, it was trained with the dialogues that switch topics. So I think it does a very good job switching.
Okay, thanks.
But feel free to try. You can try the model and see if it is able to switch topics or not.
Great. So we now move to the next talk for this session, which is given by Philipp. So he will be presenting the dataset used and published in this year's SIGIR paper, Conversational Question Answering on Heterogeneous Sources.
I don't see any slides yet.
Yeah, let's wait.
Nice.
Till we have slides.
Yeah, hi everyone. My name is Philipp. I'm from the Max Planck Institute for Informatics in Germany. And I would like to present our work on conversational QA on heterogeneous sources, which is a joint project together with Radboud and Rishiraj Saharoy. So the task that we are having here is conversational question answering, as also in the earlier talk. So we are mostly concerned about factored QA here, so questions that have a very crisp, entity-centric answer, or potentially also small spans, for example. And we give here an example of a situation in which a user might, for example, just watch the TV series Game of Thrones and is now interested in a specific series of information needs. So, for example, who played Jaime Lannister in Game of Thrones? What about a dwarf? When was he born? Release date of the first season, and duration of an episode. And what we realize is that different questions within this conversation can be targeted conveniently or more conveniently via different kinds of information sources. So while the initial question might be easier to be answered via a knowledge graph, the second question might be more conveniently answered using a text source, and the third question again via knowledge graph. The fourth might be easier via text source, and the last one, this kind of information is rather stored in a text record, for a table record, for example. So overall, we would like to move forward and integrate heterogeneous information sources into the conversational question answering system to enable this with a broader answer coverage. Another aspect that we would like to investigate is to leverage the redundancy of information sources. So the same information may be there not only in the knowledge base, but also in text and table, and we would like to account for that. So we propose a method called Convince. I will not go into the details of this method because it was presented also on Wednesday, and you can look up the video on our website or also in the SCAI video portal. And the general idea is quite similar to also the earlier talk. So we would first have a question understanding approach where we have as input the conversation history and the current question, and we want to derive an intent explicit representation of this information need. Here we would like to capture it in a structured way and construct something similar to a logical form to enable with matching with heterogeneous sources. We then retrieve and score evidences from such heterogeneous sources having an entity-centric approach, and verbalize, so we transform all these different kinds of evidences to text to treat them in a unified manner. In a final heterogeneous answering stage where we integrate such top evidences that we scored to identify the answer, and in this stage we would essentially also leverage the redundancy. So what we realized is that most existing data sets for conversational QA are mostly targeted towards a single or specific information source, like a knowledge graph or a text corpora. And therefore, we collected a new data set, ConfMix, for which we asked the users essentially to generate the answer, the questions in a natural way, and also let them use the whole collection of Wikipedia, but also Wikidata knowledge graph to answer these questions. So overall, we collected 3,000 conversations. 2,800 of these have 5 turns, and we collected additional 200 conversations with 10 turns. So these are only used for testing the generalizability of the ConfQA system over longer conversations. So we collected a total of 16,000 questions in the 5 domains: books, movies, music, TV series, and soccer. And the data was gathered via crowdsourcing from Amazon Mechanical Turk, and we only allowed master Turkers to participate to ensure quality. So as mentioned, the heterogeneity was a key aspect of this user study. So we did not force the user to, for example, at turn 5, use a knowledge graph or something similar. We let them just detect the answers in whatever information source they found most appropriate. And then finally, we ensured that they cover each information source at least once per task, so within 5 conversations. So we here plot some statistics on the data set, and essentially we show the answer sources, so either KB, text, tables, or info boxes that are needed per conversation, and we found that for most of the conversations, at least 3 information sources were used by the user to answer the questions. So we did not only collect the questions and answers, but also some metadata like paraphrases of the questions, the normalized answer to the knowledge graph, the answer source that the users used for answering, also the question entities normalized to the knowledge graph. And for the follow-up questions that can be incomplete, of course, we also collected the completed question to allow, for example, question rewriting methods to operate on this data. I would also like to quickly go through one example. So this is from the data set, and who played Ron in the Harry Potter movies would be the initial one. Who played Dumbledore? What's the runtime for all the movies combined? So these questions can also be quite challenging in general. Who was the production designer for the films, and which movie did he win an award for working on in 1980? So looking at the results of our method and also some of the baselines, I will not go into the experimental details here. And we found that when only using the current question, the incomplete follow-up question as input, the system would terribly fail. So this was definitely not sufficient. But even with our proposed method, Convince, there's a lot of scope for improvement. So we could only reach a precision at 1 of 0.34. And we are looking forward to any contributions on our data set. What we found interesting is that, so we tried different input combinations of the information source, and when given only a single source, the performance was not as good as when combining any kind of information source, so this helped a lot already, and when including all information sources, so evidences from all of these different types, the best performance was achieved. So to sum up, we propose Convince as the first method for this task, configure A over heterogeneous sources, and also release ConfMix as a dataset for this task with a total of 3,000 conversations, 16,000 questions, and 200 of these conversations have 10 turns to test the generalizability over longer conversations. Our code and data is available on our website. And with that, I would like to thank you for your attention and looking forward to any questions or comments.
All right. Thanks, Philip. Do you have any questions?
So really cool work. I have just a small question on the data splits to know how easy it is to use this data set and the method. So of course, I'm guessing the method is available, as well as the data. Do you have dedicated train, test, and validation splits, or is it just train and test?
No, so we have train, dev, and test splits available, on our homepage of the project. Right.
Excellent.
Okay.
So we also, maybe following up, we also have a dedicated Wikipedia corpus of some of the most relevant entities that can be used, probably also for dense retrievers or similar.
Please.
Could you go back to the results table? So, yeah, that one.
Yeah.
I'm curious, so why table, the performance is really bad? For knowledge graph, text, info, it's kind of like decent performance, but for table, it's really low. So I'm curious why this is too low.
Yeah, that's a good question, actually. So what we found is that, so there are 2 aspects for that. Table information might not that commonly asked in general in conversations. And the other aspect is also to understand table information. It's really hard, it's really complex, right? So these can be quite longish, the evidences that are resulting out of table records. Yeah.
Can I ask additional question? So I think that the table information is kind of like treated as a knowledge, knowledge graph, for example. So knowledge base, for example. The table has a relation between the entities and entities, right? So, do you have any, idea to treat how can we improve the performance for table?
Yeah, sure. So one kind of idea, so there are methods for, specific methods for verbalizing information that is there in tables. So this might be more appropriate for also like the current pipeline, where we are building upon a generative answering model to give a more verbalized form of the evidence as input in this stage.
All right, there are more questions?
Hi, thank you for your talk. So as a follow-up on that, did you compute this when the subset of questions that you can actually answer with any information source? So for example, the table, all questions? No? Okay.
We took all questions, so there might be, this is actually, yeah, so there may be many questions that are not answerable via tables, so therefore the performance can also be quite low. So we did not measure the performance of or plot the performance on the table information source only on data that is answerable via tables.
I
Was
have
another
another,
question.
if I may.
If you want, you can ask another.
Okay, yeah, just quick, because I didn't catch that. So the annotator asks the question and answer it themselves, or is it like it's two stages?
Yeah, so the annotator asked the question and also answered the question himself.
Okay, thank you.
Hello. Thank you for your talk. So I also kind of want to build off of why the table by itself is so low. How did you represent the table as input to the language model? Did you linearize it? Did you make sure that it wasn't truncated off, or like little details over there that can perhaps explain this?
Yeah, so actually what we did is linearize the individual rows in the table. So we concatenate the information that is there in the table together with the column header. The column header always has some context. And this way we integrated this kind of information. To maybe also follow up or give more insights, there are also not that many tables in Wikipedia. And you can also see an info box as kind of as a table, right? So there are quite some similarities.
So you're saying not that many examples in this data set had tables to begin with? I couldn't quite hear.
They have tables as the input, but actually the question might not be answerable via the information that is stored in a table.
I see.
So one other approach, for example, would also be to consider the open web, so open web tables, and these might have additional information to answer these questions.
Okay. So you didn't try any other techniques for representing the table to the model other than flattening it?
Not yet,
Okay.
but yeah, that might be interesting for future work.
Okay, thank you.
So as far as I understand, you didn't use a bidimensional encoder to encode the structure of the table. You just linearized it.
Exactly,
Okay.
yeah. You just linearize it and bring it to a textual form, essentially.
Right.
Linearize
Any other
a
question?
question. Linearize table by row, right?
So this data set certainly seems like it's got some headroom for improvement, but of course, I think as conversations go deeper, and that sort of thing, this, correct me if I'm wrong, this was 6 turns deep on average?
5 turns,
5 turns.
most of the conversations, and some are also 10 turns.
Okay. Do you think there is scope for like another version of this data set that is not only harder, but longer? And what sort of aspects would you explore in a future version?
So actually, interesting question, definitely. We were also thinking about and looking at the questions and conversations that the annotators generated, right? And we found that at some point, it's not that natural anymore to keep following up about the same topic. So I guess, of course, this only we can only gain these insights from real studies, probably also from real systems like Alexa or Siri or whatever. But what I feel is that at some point the topic might drift dramatically to a completely new thing, and then essentially the conversation starts again from scratch. So you might still need to access some of the history from like 20 turns in the past, but it might be more worthwhile to like store this kind of history in a different kind of format.
Okay. Yeah, one question that I had is like, is the dataset self-consistent? Like, is it everything? So do you have facts that contradict each other?
This is actually really interesting. So, I mean, again, this is really hard to also understand, especially with our current generative answering model. But still what we found is that sometimes, for example, the answers can have different granularities. So this was something that we observed quite commonly. So on Wikipedia, you might have the country as the place of birth, and on Wikidata, you might have the specific town or even the district in a city, for example. Also, you might have on Wikidata, you might have only the month, and on Wikipedia, you might have the exact birth date, for example. So these kinds of cases we definitely observed, and yeah, these are very interesting to take into account also in the answering phase. So how to deal with these are quite challenging.
Okay, thanks, Philipp. So we can now move to the next presenter, Hideaki. So he will present the findings published in last year's SIGIR paper titled Conversational Entity Linking, Problem Definition and Datasets.
Hi, hello. My name is Hideaki Joko from Radboud University, and today I'd like to present anti-linking in conversation. So I'd like to separate my presentation into two chapters, and the first one is that last year's SIGIR paper, Conversational Anti-Linking Problem Definition and Datasets. And the second one is the update for this research. So first I'd like to start with the first one. So background. So first of all, what is entity linking? So entity linking is detecting the mention in the text, for example, in this case, SIGIR, and after that, identifying the corresponding entities in in the knowledge graph, such as Wikipedia. So in this case, SIGIR is linked to a special interest group, blah, blah, blah. So what is different between entity linking in conversations and entity linking in documents? Assuming that we have a conversation with system and user, we can observe that, for example, in the conversation, references to the entities are made by their pronouns like my neighborhood, my guitar, or my cars, or like that. And also, all types of entities, like tomatoes, for example, in this case, can contribute to understand user utterance. So research question here is, what does entity linking for conversations entail? Whether the observation is actually true or not. So let's analyze entity linking annotations for existing conversational datasets. First, we select the datasets from the existing conversational datasets. So we studied 130 conversational datasets, and the selection criteria is multi-domain, multi-turn, and resembling real conversations. So we selected Quack, MultiWatch, Wizard of Wikipedia, and TrackCast'22. Once we select the datasets, we annotate entity linking annotations using Amazon Mechanical Turk. We asked annotators to annotate concepts, named entities, and personal entities, and also ask them to find helpful entities. So, and now we have conversations and also entity annotations. So, first finding is that the question here is that whether personal entities and concepts are actually important in the conversations. And the answer is yes. Personal entities, 33% of dialogues in the social chat contain personal entities, and also 57 of entities marked as helpful are concepts. So this means that personal entities and concepts are important in conversations. So now also the question is that whether existing entity linking method for documents are effective for conversations or not. We use tag.me, what, rel to annotate collected conversational annotations and check whether they actually work well or not. And what we found here is that the traditional entity linking tools are suboptimal for conversation. Finally, we also, the question here is that does a simple extension of traditional entity linking work? And we mentioned bike-science similarities of embeddings, but I do not go deep here in this presentation, but please read our paper. So what we found is that simple extension of traditional approach is not enough for dealing with personal entities. So the conclusion is that personal entities and concepts are important, and also traditional entity linking tools are suboptimal for conversations. So we need to develop a new method to treat conversational entity linking. Okay, so I'd like to go to the next paper, which is update of the previous research briefly. So the basic idea here is that let's solve these problems. First, I'd like to explain contributions. So in this paper, what we did is create a resource, two resources, and the first one is that create entity linking tool for conversations, which can deal with personal entity concepts and named entity linking. And also, we collected a training data set. That means that we collected additional entity linking annotations for approximately for 1,000 conversational utterances. I'd like to explain briefly about our methods. So to deal with personal entity linking, we utilize coreference resolution method and also concept linking. We fine-tune Radboud entity linker on collected annotations. So if you're interested in details, please read our paper. And what we found is that a huge improvement for performance. Yes, so thank you for your attention. And if you guys have any questions, please ask me.
All right, thank you. Is there any question? Carlos?
Cool. So my question is about the first part of the talk on the data set, specifically about the mTurkers and about bias that they could have by producing an explanation, say, post hoc. So for example, if it's difficult to assess whether an entity, as you're saying, is actually useful in the conversation, the first part of my question is, did you ask them if the entity was useful after the entity was resolved? And really, could it be the case that they're just saying the entity is useful, but not actually contributing to the answer, and they just sort of think it would be potentially useful?
Yes, for the first question, so first we identify the entities and show entities and conversation to the talkers and ask them whether the entities are important, helpful to answer the final user question as a system. So assuming that you are a system, and ask them whether do you think the entity is important as a system? And for the latter question, we do not have any specific evaluation, didn't do specific evaluation, but I think that yes, talker also has, as you said, bias, and yeah, that could be some entities which is annotated as non-helpful could contribute to systems understanding of the user utterance. So, but sorry, we didn't have any specific evaluation of that, but really interesting, and that could be a future. Thanks.
Okay. Thank you.
Question here.
So my question is about the chapter 2. I think the details were not really mentioned. So you said you solved the suboptimality problem with the coreference. Could you explain more about how you use the coreference to solve the problem?
Yeah, thank you for the question. So, so the personal entity linking is kind of like a problem of, for example, in this case, first we wanted to find my cars, and after that identify the corresponding explicit entity mentioned in the user, the conversation history. Like in this case, life and pilot is the explicit entity mentions for my cars. And this is similar to coreference resolution, because in the coreference resolution, they are interested in finding, for example, my and who is mine. But the problem here is that coreference resolution are not so interested in identifying my cars. They only identify my as a coreference. So we first use another mention detection to identify my cars as a mention and use the coreference resolution method and ask the coreference resolution method, what is the coreference or antecedent for my cars? So that is the answer.
Okay, any other question?
Awesome work, and really good to see some work on kind of high recall and linking of concepts, and I think it's really important in both conversations but in kind of general IR. I guess my question was more on the kind of personal entity idea in general and use within conversations. So normally when you're entity linking, you're linking explicitly to a knowledge base and you're using connections and so forth for downstream tasks. Yeah. So is that the kind of idea here as well, so that Honda Life would almost be its own knowledge base that you could effectively reference and use within the conversation?
Yes, but main thing that we have in my mind is that this method could be also used to populating or creating a personalized knowledge graph. For example, if user said my cars, then for this case, maybe the system can identify that our user has 2 cars, which is life and pilot, and maybe they can add these entities or relations to the knowledge graph, personalized knowledge graph. So that is the main use case that we have in my mind, but yeah, also.
Perfect, thanks.
Okay, I would say let's move to the next speaker. So thank you, Hideaki.
Thank you.
So now it's time for Carlos, who will present the GRILLBot, a flexible conversational agent for solving complex real-world tasks. And I remind you that this was the bot that won the Alexa Prize TaskBot Challenge.
Let me just check the pointer. This is working? All right, excellent. All right. So, yeah, this is really exciting. I'm really keen to let you guys know about the system that we built over the past year. Oh. Is this better? Excellent. Getting motions around there. So, yeah, let's get started. Really, this would not be possible without the team. We worked really, really hard throughout the year to work on GRILLBot, and this is work done with Paul Owoito, who is online today, Ian Mackey, right here, Federico Rossetto, Sophie Fisher, and Jeff Dalton. And yeah, so as we were saying, we recently learned that we won the competition, and we're pleased to show you guys what's happening. So really, I want to talk first about what even is a TaskBot in this context. So the first thing is, let's think about social bots. So this was what happened in previous years with the Alexa challenge. And really, these bots are meant to be a little bit more social. They are supposed to explore topics in quite a shallow way, but hop between domains fairly quickly. But essentially, they are just exploring topics in a more chit-chat kind of oriented way. The difference between a social bot and a TaskBot is that the TaskBot is actually trying to help a user achieve a goal. And so in order to help that, the system needs to be able to ask or to answer questions that are relevant in context, and also step the user through multiple different steps along the way, which might be different according to each particular user and the different goal. So in the context of the Alexa Prize this year, which was the first installment, we had two particular domains. They were cooking and DIY. In particular, both of these actually made use of both headless devices, so these little hockey puck devices that you talk to, and also the screen devices. So you could effectively leverage multimodal interaction to make things a little bit more engaging for the users. So as well, when I say DIY, these also include basically doing things around the house, fixing different kind of appliances, as well as doing crafts, origami, these sorts of things. Really, it comes down to what are the kind of things that a user can do with an Alexa that is in their house. However, the domains in particular are actually quite open, and this is down to the scope for future years of the TaskBot. So a little bit about the setting that we were going throughout the year. This was deployed around late summer 2021 all over the US for the start. And anyone that had an Alexa device would be able to interact with the bot. Essentially, what the user would say is, Alexa, assist me, and the system would essentially go through round robin, all of the other bots, of which there were 10 at the start and slowly whittled down throughout the year. And then the conversation would go through, like left and right, between the user and the system, asking questions, and at the end of the interaction would be prompted for a rating, which is completely subjective for the user, but aggregated over multiple interactions, you can yield a generalized score that can reflect the performance of the bot. So what I want to talk about in particular for this question answering focused workshop is a little bit about the types of questions that our bot is able to not only answer, but as well ask the user. So in this particular case, we actually have two particular things that we're going to focus on. One is the task representation. That's what we're going to talk about first in the context of asking the user questions and keeping them engaged, because this is really critical for long conversations. Then we're also going to talk about prompting large language models. And this will be both in the context of asking questions to the user and answering questions. Critically, one of the things that we want to look at is actually how we can rapidly iterate on both of these scenarios, because this is a competition, and in particular, this is quite a product-focused challenge. So we had to operate very quickly under different types of constraints. So really, to start off with the task representation, this is what we start with. This kind of sort of like steps, basically a list of steps that can go up to, say, 30 steps long for some kinds of tasks. The only problem is this is really boring. Whenever the user hears like the 27th step, then I think they definitely want to end the interaction. And the problem is that this comes down to the speech being very dry, and it doesn't actually conduce to voice interaction super effectively. So we had to come up with something. And the thing we came up with was a task graph. So I hope everyone can read this right now. But this is an actual example. This is a recipe that we have that represents the task, which is creamy zucchini pasta. And you'll notice it's a bit different to the previous kind of task representation that we had. In particular, we have question nodes. So these are kind of logical nodes that basically allow the user to branch between different types of utterances that allow the journey to be personalized for the user. I'll point this over here. So, for instance, do you want the sauce to be more firm is something that is said to the user appended to the last utterance over here. And so depending on this, what the user is answering, we're able to detect whether to go through one direction or the other direction, and then essentially engage the user to make it more personalized. You'll also notice that rather than just having the steps themselves, we also have ingredients. And this is applicable for both DIY and cooking. These are essentially the requirements that we have for the tasks, and they are linked to each individual step. And so this is particularly useful in screen interactions where the user actually doesn't have to ask, potentially, what the ingredients are or need to remember what they were at the beginning when they were presented. And in particular, right here, this is an example of a headless interaction where the ingredients would be said at the end of the interaction. And of course, another aspect over here that we see that is a detail in the task graph is the fact that there is additional information to each step. And this is derived from, for example, the sources in WikiHow, where you can have a short excerpt of a step, and then a longer, more detailed explanation of that particular step that's already included in the structured information that we derive from the web. And this can be passed to more types of questions that the user can ask, and then we can give them more details about that particular step. So in particular right here, you'll notice that this question right here is being asked by the system, and the user needs to be engaged. The user needs to be able to answer and say what they want to do. We also have fallback if we want to essentially ask the question again, or if the answer is not understandable, we basically have a default way to go. But the task graph representation really is conducive to a bit more interaction between the system and the user, notably from the system side. So here's another example, or here's the continuation of that same task graph. In particular, one thing I want you to notice is this other question down here, and this is basically appended again to the last part where we're able to automatically extract the amount of time that we want to set the timer for, and then we can ask the user whether it'll be useful for them to actually have the timer set. Again, I'll just point again towards the linking of these ingredients, which is useful for screen devices. So because this is, I want to cover this briefly. If there's any more questions on this, you can let me know afterwards. But one of the things that I want to talk about as well in the context of asking questions, so as we've seen before, is the fact that we can do this with large language models. So everyone here, I assume, is very familiar with language models like GPT-3 and their concept, but really the idea is you have a prompt that you provide to the language model, and the language model fills in the rest and hopefully stops at some reasonable point by producing an end-of-sequence token. In our case, one of the things we're interested in is, again, engagement. So what we're going to be looking at is actually generating questions that are useful to the user in a particular context. So at a high level, I'll show you an example later on, we have past steps, future steps, and then we're going to pass this to GPT-3 so it can generate a question. And this is the format of the prompt I'll show you just now. I hope everyone can read this, but essentially what we have here is a representation of the task, or essentially the name of the task, the previous steps in natural language, as it would be, and then future steps. And then we have the prompt itself over here with essentially the format that we want the answer in. And really, this is all about training the system for that particular context to generate a question. The fascinating thing is the system is fairly reliably able to generate contextualized questions for the particular step. And so in this case, say for example, the user is in the middle of a recipe and we're able to ask, we're almost ready to start frying the chicken, the oil needs to be at 360 degrees Fahrenheit, how is the flour mixture coming on? This is really useful for the user in order to say like, oh well, now I have a hint as to what's going to happen in the future. maybe we can talk a little bit more about this, and what we'll answer just now is how we're able to even deal with the responses that the user can have in this context. So a little bit more about that. Now we've covered the initiative side. How does the system keep the user engaged through the task graph, through prompting? Now, how do we answer these kinds of questions? And really, this boils down to two kinds of stages where we are, where we have the user journey. So a TaskBot in general consists of two stages, which is finding the task and then helping the user do this task. So we have types of interactions such as chit-chat, where the user maybe needs to say something like, oh, what's your favorite recipe? And that sort of thing. This happens quite often. In general, we actually have to handle every single part of the interaction with the user. And oftentimes the user can say nonsense or even just want to say trivial things like chit-chat. Furthermore, we have open domain question answering. So these are things that are potentially unrelated to the task, but more like they would expect the system to be able to answer certain things like this, like what is the food capital of the world? But really, these are open questions and need to be answered fluidly. Furthermore, we have questions about the system. So for instance, if the user needs to ask, what can you do? For instance, this has happened quite often to us, where any kind of sort of specific domain QA or contextual QA will not be able to answer effectively. So we need a system that can effectively and concisely communicate what the system is capable of to the user. We also have task comparison questions. So for instance, if we have three recipes for the user during the finding the task stage, the user might ask which one is better or which do you recommend. These are more things that we have to handle. And finally, we have task question answering. So these are contextualized questions that will take place during the task, things that are relating to the ingredients or the steps themselves. And so the way we handle this at a high level is basically we have a federated approach where sometimes we'd use the large language model, sometimes we'd use Amazon Evie, which is an endpoint provided by Amazon that is based on knowledge-based question answering, and then we have a fine-tuned version of unified QA for particular situations where the answers are fairly trivial. But what we're going to talk about just now, and in general the main focus of this talk, is a little bit about GPT-3 and how we actually enable pretty effective question answering with zero-shot. So here's a bit of a problem when it comes to making a TaskBot question answering system. There is no data, and it's really difficult to iterate on models because there is no data, and it's also a very difficult problem because there are so many different types of questions as we've seen before. Furthermore, for example, an example that we have with unified QA is when you actually pass a question that is not very relevant to the system, it tends to hallucinate really badly. You will see, like, for example, who are these experts, which is an actual question we had during a finals interaction. It just hallucinates some part of the recipe that is not relevant. And so this is a bit of a problem, as we see. And this is sort of due to the fact that these systems are trained on academic data sets. They are maybe not meant to handle out-of-domain questions where the answer is not necessarily in the context. And so we see like these sorts of problems occur quite frequently. So I want to point out some of these other kinds of prompts that we've been able to use in order to alleviate these kinds of problems. This is a task comparison one. So for instance, if the user says, which do you recommend? And in this case, we have 3 recipes that we would format to the model. By the way, as with the previous examples, these are actual prompts. This is the actual format of these prompts to the model, which is GPT-3, that would be able to use for question answering live. And effectively, when you see the prompt being able to describe what kind of answers we're expecting from the system is able to not only give a fluent answer, but also able to rely on the knowledge it has in its weights to provide a little bit more spice to the answer and include a little bit more knowledge, such as the fact that he's a well-respected authority on noodles. Despite the fact that this is fluent, there is a limitation on this, which is the fact that the model is just relying on the weights. There is no external information relating to J. Kenji Lopez. It's whatever the model has inside during training. Finally, here is an example of task question answering where we have the step text, which would be pretty long, and we have in this prompt the fact that it's contextualized by the title of the recipe. It's talking about the topic, and this is essentially a fallback, which will say, like, if the system is able to identify the fact that this question is not answerable, we'll be able to say, good question about whatever topic it is, and then, but the task doesn't actually say. And this is particularly useful for users when, for example, if a system is not able to identify that it can't answer the question, then the user might get a bogus question back. And the fortunate thing is that large language models like this actually have this baked in when you use the prompting in the right way. And here's the examples for that. So before I close off, I actually want to talk a little about the prompting limitations. So one of the things we've observed when using these large language models is the fact that you cannot include too much context into the model because it will get confused. And the thing is, when you actually start including task steps, if you'll remember, I was talking about 30 steps. This can be quite long. There are viewing options. There's, for example, the GRILLBot bibliography or biography, basically, the amounts of ingredients. It is unsurprising that a language model can then start hallucinating when the context is just so much all over the place, especially considering that these are unidirectional models and don't necessarily know what you're going to be answering or even asking of them. So in order to solve this, we made a simple classification method based on SBERT, which isn't really super special, but what is interesting is the taxonomy that we came up with, which is effectively covering a little bit the different aspects of the bot surrounding these two domains on ingredient questions, task questions, and so on, which you can see examples over here. These examples are actually part of the overview paper that we've published as part of the proceedings of the Alexa Challenge. And if you want more details, you can refer to that as well. So overall, with these question answering systems, how well did we do? The cool thing is that we can actually see performance is really quite effective once the conversations are long. And one of the things we observed throughout the competition, as well as a steady increase in our ratings performance, is that while at the beginning people are mostly interested in exploring the system and really seeing what its capabilities are, such as can it play music and that sort of thing. Once GRILLBot and the user really start doing something together, the ratings really show that GRILLBot is able to hold its own in terms of question answering and a sort of interaction through the system. So really, I'll just close off. Just a quick thing, the clicker isn't working. Could we move on to the next slide? I'm just not able to click next. Yeah, anyway, this is, I just want to point out that this is the last slide. And if there are, oh, here we go. So the takeaways a little bit that we want to get from this presentation right here is the fact that task graphs, the way we've formulated them, are really conducive to initiative from the system side and personalizing the journey for the user so that they don't get bored. This is the primary objective because ultimately the decision is subjective for them. And the second part is just how useful large language models are for rapid iteration in a production-oriented setting, specifically on complex behaviors such as creating contextualized questions, and also for really rapidly iterating on different kinds of question answering systems when you just don't have any data. So a couple things that I maybe want to point out for the discussion is the fact that we've used large language models as well for other purposes in the Alexa Challenge, but they didn't factor as part of the final bot for a couple of reasons. But effectively, they are covering synthetic data generation and also generating structured data where we're basically leveraging the knowledge inside the weights of these models to help us provide a little bit more information for the user. And with that, I want to close off with the fact that GRILLBot is actually open. If you weren't here on the tutorial on Monday presented by my colleagues here, it's now called OAT, the Open Assistant Toolkit, which can be seen over here. And it incorporates the core elements of what made GRILLBot, basically the decision making, some of the question answering, some of the initiative. So if you are interested in things like this, you should absolutely check it out. Awesome. I I will take questions just now. Thanks for listening.
Thanks. So we will have only one question, so then we move to the
Hello, thank you, this was very nice. On the very first task graph slide, there was a particular question of like how to make the sauce more firm. Don't ask me why I thought of this random. But anyway, where did this question come from? Because it seems like a rather task-specific and knowledge-intensive question. Like you can't just pull it out of thin air. You have to know something about the recipe and its properties. Where did this question come from?
So, really good question. Here we're focusing on the representation itself of the task graph. However, the curation of the task graph, how we created it in the first place, is currently manual. So basically, when we want to create tasks that are quite complex in nature, we have to inject quite a lot of our knowledge when it comes to making these questions. We were very keen to think about creating these automatically for a large number of tasks, but it is a very difficult problem, one that is difficult to solve in a year.
Do you think, just building off of that, do you think you could use the large language models and give it enough information to build these kinds of very useful questions that are not just like random opinion questions, but these kinds of things?
So I think in the capacity, it really depends on the ability, on what kind of language model you're using. So these systems are very capable of understanding context and leveraging a lot of the information they have in their weights. However, if you use something like GPTJ, you will be limited on the ability for it to understand the context and really base its answer or base the question off of that context. If you leverage a larger language model, you'll be able to do better. But I do think if you frame it in the correct way and you constrain those questions, you'll be surprised what you'll be able to do.
Thank you.
Okay, thanks. So I think now we can start the discussion. So if the other speakers just come to the stage. So while you're coming, so a question that I'd like you to answer is basically how do you see the future of conversational question answering? Or in other words, like, is there anything that we are overlooking in IR that you believe is going to be important? I mean, you have 1 minute each. So.
Okay. Shall I start? So the question is the future on conversational question answering and a little bit the role that it can play in IR. So I think the future of one of the main challenges that we face right now is on the evaluation side. I feel like conversational question answering systems can either be very, very factoidy, and they can be assessed with certain kinds of metrics that are easy to use, such as exact match. But for true conversational systems that are open-ended and that leverage summarization or multiple documents or different facets of information seeking, this is a bit of an open question currently. And I think it's something that is limiting our ability to push forward because we can't actually identify where the problems are. So that's my 1 minute answer.
I would also like to add to this that actually in a real system, as we also saw in the last presentation, you might have not only like factoid questions, but I mean you have the task-oriented part, you have all these different facets, and you don't really have these data sets currently available, and you have to model all this in some form of conversational history. And depending on the current question or information need, you need to detect the most important part of this ongoing conversational history, probably also like personalizing this kind of history. So I think this is really a key challenge.
So I'm kind of like on the same page as Carlos. I think that one of the challenges is evaluation. And especially I think that recently a lot of, conversational system use the generative model, but we still do not have any evaluation metrics to evaluate the naturalness of the answers from the systems. So for example, dialogue system community, they use, for example, language models to evaluate the naturalness of the system utterance. So maybe we can also look at the other communities, how they're dealing with this kind of evaluation problem, and maybe we can learn better from them.
Gonçalo next.
Can I also? Okay. I'm also compelled to agree. Can you listen to me?
We can't hear you.
Okay, now yes.
Okay. I was going to say that I'm also compelled to say that the evaluation is probably the most critical factor to advance the models that require generation. But to add to that, I think that maybe decoding methods may also play an important role because many times we generate answers that either hallucinate or have inconsistencies, and so I think that it would also be relevant to study the decoding methods used, and relating to IR, methods that are able to take advantage of the retrieved information instead of only the knowledge of the pre-trained weights.
Okay. So yeah, definitely like evaluation of conversation system is a big problem. And yeah, what I was wondering when you were talking about this, since you kind of all agree, is what could be like a good metric for evaluating a conversation, or in other words, like what makes a conversation good? Yeah. So, what would you say makes a conversation good? And of course, you cannot say engagement. Like engaging conversation is not allowed.
So I started last time. Does anyone want this one?
Yeah, so for me, really, I think that evaluating conversational QA systems can only be done in a realistic way by making user studies. So measuring user satisfaction over the turns, whether the user's goal is actually satisfied, this is like the key thing, I guess, to how to measure the quality of the system.
Yes, I'd like to talk about this from the little bit different perspective, but I think that, yeah, current conversational search system do not deal a lot about the personalized setting. For example, if you ask to the system about the more kind of like personal thing, then the system easily fail to answer those kind of questions or easily hallucinate. So I think that incorporating personalized information to the knowledge, to the language model is also really important here to solve, user satisfaction like
that. May I?
Yes, please.
I'll probably introduce some other areas like in machine translation. There is also the problem of evaluating generation, and there are some dense, some metrics based on dense models or in transformers that seem to correlate well with human judgment, and probably being able to identify some critical mistakes at some sort of ranking of how bad is this mistake should improve the generation and help us evaluate a dialogue. Such that, as for me, when I try a chatbot, the first thing I do is try to mess it up, like give him some queries that I know are hard, and if we were able to identify those particular questions that are harder, maybe we would be able to do a more precise evaluation.
Okay, thanks. So, do we have any question from the audience that you would like to ask the panel members?
I'll just comment on Philipp's answer, because I feel like
sure.
actually the idea of doing of being constrained to do user studies or to evaluate a system is quite limiting in terms of the capacity that one can have in order to do evaluation. It really sort of can limit the iteration speed and sort of make people not able to test all the aspects of the system or at the correct depth. I feel like what needs to be my intuition from using these systems and working in production in this way is that you can actually disentangle different aspects of an answer in terms of fluency, factual accuracy, in terms of facet discovery, and encouraging the user to find different things. You can also potentially quantify engagement independently of these different factors. And so rather than having engagement as a single metric, I think potentially having further, like more metrics that evaluate or different aspects that are orthogonal would be possible. And I don't think, I think only using user studies could be too limiting, and I think there are other ways of doing that.
Yeah, so I would like to comment on that, basically. Yeah. So I guess that I agree totally for the development of conversational QA systems, right? So for developing these, this is much too expensive. It's too expensive to tune the individual components. But in the end, I feel for really understanding of what works best in practice after the development is kind of done, I feel personally that the user satisfaction is kind of the best thing to measure really the quality of the system.
Okay. Any question from?
Hello.
Please.
I've already been given the mic.
Okay, you already have the mic.
Laura, you can have it after. I guess my question was, do you think the conversational community is too over-reliant on query writers? Because obviously right now the standard practice seems, you take the context, you rewrite the query, and then you use kind of fairly standard kind of QA systems. Unlike, let's say in the future, having to use all the context within the retrieval and building in new models. How do you see that sort of progressing, and do you think as a community we are too reliant in these kind of like two-stage approach?
So who wants to take this?
Maybe I'll start. So I think it's actually a very useful tool to have this split up into two parts, primarily because query rewriters are actually interpretable. You can actually see what the rewriter is producing, and it provides a breaking point where you can see if you need an improved retrieval system or if you need to improve the rewriter. I think in general, what we're seeing with these rewriters is that you can stop a conversation midway and then sort of freeze it in time through a resolved query. And I think while it's true that dense retrievers that incorporate all aspects of the conversation can be effective, they are a little bit too much of a black box to really be able to pinpoint where the problems are. And I think the distinction can be really useful to drive progress.
Okay. Laura?
My question is, so I think like a lot of you sort of rely on like pre-existing components, like either provided by Alexa or out there. And my question is sort of like, number one, which of these components are really like the most important ones? Number two is, what are components that you really, really wish were out there that aren't quite yet? Like components that you, not just systems, but like components that you would build a system around. Was that too hard of a question? I'm sorry.
So, is this specifically directed around
I think
the Alexa, or like
no,
Alexa in general, or is it like in
that was just an example, right? Okay. I mean, like most of these systems are kind of like baked around some components that already exist. For like things, like little things, like a semantic parser, for like knowledge base, entity linker, retrieval setup.
Yeah.
And
May I?
If I can add also, like, there are several components that try to do the same thing, right? And they are just, maybe trained differently, or maybe they are different techniques. So maybe like follow-up question could be like, so which one of these components actually is going to survive, the test of time, and which one is going to be forgotten? May
I try to answer? as for me, in terms of components that I would like to have, I would be more on the, in my pipeline, I would be the last component, the generation, models, multilingual models, because right now, most of the pre-trained models we have available are English-based. And I think it would be helpful. I think everyone would like to have a model in their own language. As for, sorry, I'm trying to recall the entire question. Maybe to add to this, it's a bit difficult to obtain or to train ourselves these models, sometimes because we don't have enough data available. When I'm talking about these models, I'm referring to pre-trained transformers that most of us use. So it's hard to sometimes get enough data to train the models, and also to train the models when they are too large. So as for me, I would be unable to train a GPT-3-like model. Only fine-tuning, and even fine-tuning, sometimes it can be too expensive, depending on the input sizes that we use. And that is one of the limitations of using vanilla transformers. Maybe I would like also to see some development on sparse transformers or linear attention. Yeah, that would be interesting.
Okay, so I think to address which component will stand the test of time, I think part of the question. I think what we're seeing nowadays, as I've just shown in my talk as well, is the fact that right now we're relying on a lot of the knowledge being encased in the weights of these systems. I think, as a lot of the research is pointing out here, relying on external collections to store the information and having the model as just an interface is an approach that can be scalable and that is likely to stand the test of time, given the fact that we'll be asking these systems to do more and more with different sources of data that they will not have seen during pre-training.
Okay, anybody else wants to add something?
Yeah, I mean, with respect to also like single modules that are very important, and like also all of these different types of conversational QA. I mean, they're task-oriented. One is very different from the factoid or also open domain one. And I think that some component that aims to capture the information need, or also like the current context and some self-sufficient representation, may it be some question rewriting, may it be some structured, whatever form of the context or of the current information, I think this is essential for any conversational QA or any conversational method in general.
Hideaki.
So I think that given that, for example, WordTVec, which is created like 8 years ago, are still used in some contexts. For example, Wikipedia Vec is still used. So I think that one of the things is, if you create a really great package which is really, really usable, then I think that that kind of tools or methods are continuously used in a community, I think.
Okay, so I would like to thank the panel. So with this, we have reached the end of this session. So now it's time for the coffee break.